Hello. This will be a demonstration of Proposition 25 from Book 8 of Euclid's Elements, which says that if two numbers are to one another as two cubed numbers, or in other words, that the ratio between two numbers is the same as a ratio between two cubed numbers, and if furthermore the first number is itself a cubed number, then the second number will also be a cube number. We're given two numbers A and B, and the ratio of A to B is the same as the ratio of the two cubed numbers C and D. So A is to B, just as the cube number C is to the cube number D. We're also given that the number A is itself a cube number. And with this, we want to prove that the number B is also a cube number. Now, because the two numbers C and D, they are both cubes, we were given that. They're obviously similar solid numbers. They fit the definition of similar solid numbers, which is definition 7.21. So C and D are similar solid numbers, which then means by Proposition 8.19 that two mean proportionals must fall between C and D, because what that proposition tells us is that between two similar solid numbers, there are two mean proportionals. So C and D being two similar solid numbers, there are therefore two mean proportionals that fall between them. But we know C is to D just as A is to B. We were given that as well, which then means also that between A and B, there are another two mean proportionals that fall between them. We know this from Proposition 8.8. So because C is to D just as A is to B, and there are two mean proportionals between C and D, by Proposition 8.8, there are two mean proportionals that fall between A and B. Now, we know that the number A is a cube number. We were also given that. And we also know from Proposition 8.23 that if four numbers be in continued proportion, which is what we have here, we have A, the two mean proportionals, and B forming a continued proportion made up of four numbers, that if the first number is a cube, the fourth number will also be a cube. So that because the first number A is a cube number, the fourth number B is also a cube number, which is what we set out to prove, which means we're done with the proposition, therefore, etc., QED. What this would look like is that 64 is to 216, just as 8, a cube number, is to 27, another cube number. Furthermore, we also know that 64 is also a cube number, which then means, by this proposition 8.25, that 216 is therefore also a cube number, which is easy enough to verify, so we see that this proposition holds. That's all I've got to say about this one, so I'll end the video here and move on to Proposition 8.26.